Termites cause billions in damage, and no homes, whether old or new, regardless of type, is safe from an infestation. Based on estimates in 2010, global economic impact of termite pests had reached $40 billion, 80% of which is accounted for subterranean termite costs. Even with the introduction and development of termite baits, application of liquid termiticides in subslab soil still remains to be the primary method used by the industry to prevent and treat active infestation of termites. Thiamethoxam, the active ingredient in Optigard TL, is a second-generation neonicotinoid insecticide that belongs to the thianicotinyl subclass. It provides contact and ingestion activity in multiple stages of insect development. Thiamethoxam targets the nicotinic acetylcholine receptors in the insect's nervous system, resulting in death of the exposed insect. Neonicotinoids have a significantly different mode of action compared with other classes of insecticides commonly used for pest control. Thiamethoxam is non-repellent and can be transferred from exposed to unexposed insects that exhibit social behavior such as termites. Thiamethoxam has demonstrated ingestion and contact activity against higher and lower subterranean termite species, drywood termites, and powder post beetles. Optigard TL is readily transferred throughout social insect colonies by foraging workers, resulting in control of workers and reduction or elimination of colonies. Optigard TL has low acute toxicity to mammals by oral, dermal, and inhalation routes of exposure. Skin and eye irritation studies indicate that thiamethoxam is not mutagenic, teratogenic, neurotoxic, or a developmental toxicant. The U.S. Environmental Protection Agency categorized thiamethoxam as not likely to be carcinogenic to humans, the lowest possible classification for carcinogenic potential of chemicals. Toxicity studies on thiamethoxam have demonstrated a wide margin of safety to humans when applied following the label's directions for use and rates. Leaching of thiamethoxam to groundwater is not expected to occur at concentrations that may raise any toxicological or ecotoxicological concerns. Moreover, thiamethoxam has a low vapor pressure, therefore, volatilization from soil or water is not expected to be significant. Remen and Su evaluated the speed of kill of thiamethoxam against Coptotermis formosanus, a close relative of Coptotermis vastator gestroi, which is widely distributed in Southeast Asian countries. Their results show that thiamethoxam is slow-acting at 5 parts per million and suggests that this may have an impact on the foraging population of a subterranean termite colony. Remen and Su evaluated the non-repellency of thiamethoxam against Coptotermis formosanus shiraki. Their study showed that 8 parts per million of thiamethoxam provided an effective barrier against C. formosanus. Moreover, sand was penetrated to some degree from 0 to 800 parts per million, revealing that it is non-repellent. Experiments were conducted to study the AI transfer of different insecticides between workers of subterranean termites. Thiamethoxam treatments had very high AI transfer properties between the workers. All the termites died within 3 days in the 50 parts per million thiamethoxam treatment. At 0.5 parts per million of thiamethoxam, 89% mortality was observed within 7 days. The exposed workers all died within 5 days, and the healthy workers who were exposed to the treated workers died within 9 days. So the estimated minimum effective dose for AI transfer was 0.5 parts per million of thiamethoxam. Only 77% mortality was observed with 50 parts per million of imidacloprid treatment in 7 days. At lower rates of 10 and 1 parts per million, only 4% and 3% mortality was observed respectively. So the minimum effective rate for AI transfer for imidacloprid was 50 parts per million. In the 50 parts per million fipronil treatment, 100% mortality was observed within 7 days, while 79% of mortality was observed at the 10 parts per million rate, and only 7% mortality was observed with a 1 parts per million rate within 7 days. So the effective rate for AI transfer for fipronil was 10 parts per million. In the Vitantrin treatment, there was a knockdown effect at 50 parts per million, where 31% mortality was observed within 7 days. Bifenthrin, being a repellent insecticide, the healthy workers were repelled from the dead workers and no AI transfer was observed.